Hello, in PowerFactory we have something called N-1 analysis or contingency analysis. For doing that, maybe we can open one example, maybe IEEE 9 bus system. Okay, so we have this power system. Here we have the ring configuration. We have three generators, three transformers that connected, and also three loads. And here we have a couple of lines, 6 lines that makes a ring configuration. So in this situation, the system is working very well in steady state. And if we have, for example, some load here, the power flow going from this direction and this direction, from two directions, you can see that. But is on this case study, assume that if we want to see, okay, if we remove or have an open circuit on this line, for example, if you have a fault here, we have open trip signal to these circuit breakers, this open from two sides, this line is open, then we have the connection of the load from this side. And the power go to this load from this side, but we don't know how much voltage drop we have, how much issues we have, because we have some loadings here. So the toolbox that we have for this is contingency analysis. If you click on that, you have these options here. So here, if you click on contingency definition, here you say that, okay, which type of faults on which type of elements you can have. So here is outage level n-1, meaning that we have n different topology and different components, and 1 is not there. So n-1. n-2 is two not there. So n-1 is more likely to happen. And here it say that, okay, which component just shut down, lines, transformers, series, and capacitors, and you can check or uncheck the generators. If you click execute, then the library, the case study is made. If you click on contingency analysis, here you can make the analysis, but you should have you should add the contingencies here. If you click on add case and groups, here on fault cases, this is a thing that you made on previous step. So you should select all of them. Okay. And we have 9 cases. Click execute. And now we have 9 different load flows for different studies. So here, if you click on the second option from right, click execute, then we have the output of the contingency analysis. So it say that in two scenarios, if this happening, if transformer 1 or transformer 2 is going out, we have some high loading in one of the other cases. So if transformer number 2 is just open circuited, is faulty, for example, then in transformer number 1 we will have 91% overloading. It's obvious because if we have the shutdown on this transformer, the generator number 1 should produce more, so we will have higher loading to this one. And if line 4 to 5 is just open it, then we will have a huge loading on the transformer number 2. So if we can apply also the same methodology on the other power systems.